So the strategy we used in the previous video to resolve collisions was open addressing. Specifically, it was open addressing using a linear probing. Now, linear probing means that what we do is that if we are looking for a key at a specific spot, if it's not there, we look for the next available spot, then the next available spot. And next meaning in that case is defined as basically +1, and then +2, and +3, at the +1, +2, +3 being relative to the spot we were initially looking at. We don't look 1 away, then 2 away, then 3 away. Okay. On the other hand, that's not the only way to resolve collisions for open addressing. We could also do something called quadratic probing. Okay, if we get a collision, we'll look for the next available spot 1 away, then 4 away, which is 2 squared, then 9 away, which is 3 squared, then it would be 16 spaces away, and so on and so forth. Now, it's the advantage here is that we will spread out our keys a bit more, right, rather than clumping them all into a big cluster. The disadvantage is that it is a bit more expensive because of a multiplication operation. But that's just another way of dealing with open addressing. The other overall strategy is to do something called chaining. Now, chaining, let's see if we can't resize this. As you remember, oh, yeah, that is terribly oversized. Right? Chaining, the idea here is that rather than dealing with the collisions by looking for the next available space, the entire way to do this is that every space in here is basically a linked list or an empty linked list. This is sometimes called bucket hashing, and a linked list is sometimes called a bucket. And basically, if you get a collision, you just drop that item you're inserting into the same bucket. You add it onto the end of your linked list. So if we were to add another item here and it were to end up getting hashed to the value of 3, it would just simply get attached to the end of this linked list over here.